All right, we are doing section 3.7. This is the last section of chapter 3. Woohoo! Which means that your test is soon, but we are almost done with chapter 3. I am not going to do this warm-up right now. You should, so pause it, do the warm-up, and then we'll continue. But I'm not going to do this one with you. We are going to do uniform motion. So this means that two things are moving at the same time, okay? Whether it's cars or people or animals or whatever it is, planes or trains or could be anything. Two things moving at the same time. There are two different ways that we're going to do this. Either the two things that are moving in towards each other. So like they're about to run into each other. Or they are going in the same direction, kind of working against each other. Okay, those are the two main ones that we're going to work on. So are they coming towards each other, or are they going like away from, well, they could be going away from each other in opposite directions, but that's similar to coming towards each other, and we'll talk about it. So these two are grouped together, or they're working in the same direction, both going the same way. We are going to use the distance equals speed times time. So I know you also do this in science. If you haven't done it already with Mr. Donegan, you will. So how fast you are going, speed, multiplied by how long you are traveling at that speed. Okay, so you're going 2 miles an hour, but you do that for 16 hours, you're going to go a lot further than if you would just do it for 1, okay? So your speed, so how fast times how long, gives you your distance, how far. That's the biggest thing. We are going to make little charts for these questions. They're not nearly as important as they were before. They're much less complicated. It just kind of helps to sort out your information a little bit before you go straight into making an equation, but they're not nearly as complicated. But this is the biggest thing you need to know, that speed times time gives you your distance. So for the chart, it's only 2 rows, and it's pretty simple. These are just the first thing, or there's the two things that are moving. Okay, so car 1 and car 2, or Jake and Diane, or whoever is moving, or what is moving, goes in those first 2 boxes. How fast they are moving goes here. Okay, how fast are they each going? So this is going to be like miles per hour, something like that. Time, sometimes we know the time and sometimes we don't. Sometimes this time is just going to be t. Other times it's going to be an actual value. And then the last column, you multiply your speed times your time, which will give you your distance, okay? So 2 trains are heading toward each other on the same track. Currently, the trains are 53 miles apart. One train is traveling 75 miles an hour and the other is traveling 40 miles an hour. If this continues, how long until the trains collide? So we need a little chart. It doesn't have to be elaborate. And we're going to do, this is speed times time equals your distance. And we just have 2 trains that are moving. So you can just call them train 1 and train 2. Speed, we definitely know the speeds. Okay, one train is traveling at 75 miles per hour. So train 1 speed is 75. And then how fast is train 2 going? The other train is traveling at 40 miles per hour. So train 2, 40. Okay? This says, if this continues, how long until they collide? So they're asking you for time, which means you don't know it. But here's the deal. They start at the same time and they end at the same time. It's not like train 1 is going to collide an hour before train 2 does. They're running into each other, right? So that's going to happen at the same time. So I don't need to have different variables for that. Their time that they're running into each other is just t. Both of them. They're going to run into each other at the same time. I don't know what that time is, but I know it's going to be simultaneously. So they're both just t. The last column, you just multiply the middle two. So 75 times t is 75t. And 40 times t is 40t. Okay? So that's the distance. So this is how far train 1 is going. This is how far train 2 is going. Now, sometimes it helps to visualize it. Usually I have kids come up to the front and run into each other, but we can't do that right now. Let's do a different color. All right, so here are my trains. Train 1 is going 75 miles an hour, so that means it's going to cover more distance because it's going faster, okay? Train 2 is going 40 miles an hour, and they're going towards each other. They're on the same track, okay? My blue train is going faster, which is why it is a longer line. Train 1 is blue, and train 2 is red. So 75t, that's how far it's going to go. And 40t, that's how far that one is going to go. Those are their distances. Now, we did kind of ignore something that was happening in the question. It says that the trains are 53 miles apart. Oops. That means that we know from the start of each of those trains originally, they are 53 miles. So, train 1 is not going to travel 53 miles all by itself because train 2 is also moving. Okay, neither one of them are going to cover the entire distance on their own. Train 1 is going to do part of it. Train 2 is going to do the other part of it. Even though we don't want them to run into each other, they are still working together to cover that distance. They are each doing some of the work. You can see that by looking at those arrows. So train 1 is going to cover more than train 2 because it's going faster, but it's only going to do part of the work. But together, between those two pieces, they're going to go a total of 53 miles. So we're going to write our equation based on the fact that we know they're going to work together. So however far train 1 goes, that's 75t. And however far train 2 goes, that's 40t. Together, they're working together. So you're going to add them. They're working together. They will go a total of 53 miles. So the distance from train 1 plus the distance from train 2 is equal to the total distance of 53. And after that, you're just solving it. Well, the t's are on the same side of the equal sign, so all you do is combine them. So 75t plus 40t is 115t. And then you divide 55 by 115. And you get 27.6. All right, so t, we should know, is representing time. That's why we picked the variable t, the descriptive variable, to help us realize what we were solving for. My question to you is, if you're going to go to your friend's house, do you call them or text them and say, I'll be there in 27.6 minutes? Probably not. That doesn't, wait a second, 53. Oh, sorry, I jumped ahead of myself. Huh. We're not in minutes yet, we're in hours. And so 55 divided by 115 is 0.46. That makes more sense. Sorry. Okay, so T is 0.46. Again, we're talking about miles per hour, so that's hours. So you don't call your friend and you don't say, I'll be there in 0.46 hours. Nobody talks like that. That doesn't make any sense. We know that the trains are going to collide before an hour because it's a decimal, okay? So in less than an hour, they're going to collide. But let's put that in terms that make sense to us. How many minutes are in an hour? 60. So you're going to do 0.46 because that's how many hours. And you are going to multiply it by 60 minutes. Okay? All right, that's where I get 27.6. This is minutes. This one was hours. All right. So they're going to collide in 27.6 minutes. Still not a great way, but 27 minutes is useful to us. Let's turn 0.6 into seconds to help us get a little bit better understanding of when these trains are going to run into each other because it's kind of important. So you're going to do the same thing. You're going to do 0.6 times 60 because there are 60 seconds in a minute. And you get 36 seconds. So they will collide. So the trains will collide. You're still giving me words. In 27 minutes, 36 seconds. Okay, so again, they were working together to cover that distance. So we added their distances, 75 and 40. Got 115 T, and their total distance was 53. My goodness, I'm struggling right now. 53. Okay, so their total distance was 53. And then you divided 53 by 115, and you get 0.46 hours. Doesn't make any sense. So you multiply that by 60 to give you minutes. You get 27.6 minutes. Kind of makes sense. The 27 minutes part does. But then instead of 0.6, we usually turn that part into seconds. So then we multiplied 0.6 by 60 to get 36 seconds. And then the trains will collide in 27 minutes and 36 seconds. All right. Make a little chart. Ooh. Two cyclists begin traveling in the same direction on the same path. One travels 20 miles an hour while the other is 14. How much time will cyclists be? After how much time will the cyclists be 15 miles apart? Okay, so these are bikes. So we'll just say bike 1, bike 2. Remember, we're doing speed, times time equals the distance. So how fast are they going? Bike 1 is going 20 miles an hour, so 20. Bike 2 is only going 14 miles an hour. It says after how much time. So again, we do not know how much time, so we just use T, but the time is always going to be the same for both of them. And then to get the distance, you always multiply the two together. So 20T and 14T. That part's pretty simple, okay? Figuring out what they're doing is a little bit more complicated. Bike 1 is going faster, so it's going to have a longer line. But it says they're traveling in the same direction, on the same path. So bike 2 isn't going as far, but it's starting in the same place. and going in the same direction. So bike 1's distance is 20t, and bike's 2 distance is 14t. The way I want you to think about this is I want you to think about one is chasing the other. So it's like a race, okay? They started in the same spot, and then they said go. So they started at the same time in the same place, and they said go. So we want to know, you win the race once this distance is 15 miles. Okay, you have to be 15 miles ahead of the other person in order to win. Okay, so how long will it take? They started together. How long will it take for the faster bike to get 15 miles away from the slower bike? So if it is a race and you're chasing someone, okay, you're chasing them, you're trying to catch them, you want to win, you guys are actually working against each other, okay? Even though you're going in the same direction, you're trying to get ahead. You're going against them. They're trying to make it harder for you. If they would just sit there and do nothing, it would be simple, okay? But they're not making it easy on you. They're chasing you, so it's harder and harder to get further away from them because they're still trying to close that distance. So your distances are the same. Your distances are just 20t and 14t. That's not the problem. The question comes when I'm not working together anymore. It's not like, hey, I'll do some of it and you do some of it and we'll meet in the middle. It is, I'm trying to get away and you are trying to make that more difficult for me. So you guys are working against each other. And so when you're working against each other, you have to subtract your pieces, okay? So that's the biggest question you have to ask yourself. Are they working together or are they working against each other, okay? We need their distance at the end to be 15 miles. That's when you know you win. So that's 15. Okay? And then from here, you just solve it. Let's see if I can do this one a little bit better. 20t minus 14t just gives us 6. And then you're going to take 15 and divide it by 6. So t equals 2.5. This is in hours, okay, because this was in miles per hour, so your answer is in hours. 2.5 hours actually isn't that bad of an answer. It's 2 hours, so that's straightforward, and 0.5 is just 30 minutes, okay, it's a half an hour. If you want to, you can say 0.5 times 60, and you get 30, and this is minutes. So 2 hours and 30 minutes. So the bikes will be, write me your sentence. "15 miles apart after 2 hours and 30 minutes. Or you can say 2.5 hours, that's fine. Okay? So here's the biggest thing you need to know. If they are working with each other, they're going in opposite directions. See, the blue one was going to the right, the red one was going to the left. They're going in opposite directions and they're working together. You add. Here, the blue one is going to the right, and the green one is going to the right. So they're going in the same direction, which means they're working against each other, so you have to subtract. So that's where these pieces come in. Opposite directions, you add. So if you want to add your little arrows to make it easier to visualize, opposite directions towards each other. You're adding. Opposite directions also accounts for starting in the same place in the middle and going away from each other. Same thing, okay? Both of these you add. If they are going in the same direction, then you subtract because they're working against each other. So if one's going this way and the other one is going this way, then you subtract. Okay? This is kind of confusing with too many colors. Okay. So you add if they're going towards each other. You add if they're going in opposite directions against, like opposite, starting in the same spot and going in opposite. And then you subtract if they're going in the same direction. Okay, let me know what you need. Bye, guys.